So this is the third problem in the question bank. This is a very important problem. It frequently appears in the examination. Let us see what the problem is. A telegraph wire hangs in the form of a curve. A wire which hangs in the form of a curve. The curve equation of curve is given as y is equal to a into log sec x upon a. A is a constant. We have to prove that curvature. Now this is important. Curvature at any point is, so in the initial video I have explained that curvature is a reciprocal of radius of curvature, is 1 upon rho. Okay, so remember that we will need it in the last step. So the equation is given as y is equal to a constant into log of sec of x upon a, and point is not given. At any point we haven't been asked, so we need not to put the point in that. Now let us differentiate this equation, differentiate with respect to x. Now here, in order to find derivative, it is composite function, so we will need to apply the chain rule. Now let me explain what the chain rule is. If y is equal to function of g of phi of x, for example, here there are three functions: first function, second function, and this is phi of x, this is third function. Then dy by dx, while finding dy by dx, we first find f dash, we differentiate this of this all, and then again derivative of inner function we find. Inner function is g of phi of x. Then in next level we find f dash, g dash, dash stands for derivative, g dash, and then again derivative of phi of x. So this is the chain rule. We go on differentiating from outer side to inner side. Here there are three functions, 1, 2 and 3. So first we assume that this all is x, and this function we see as a into log x. So derivative of log x is 1 upon x, so it will be 1 upon x is this all, 1 upon sec x upon a into derivative of x, what we have called x is sec of x upon a. This all we have called as x. Now let us move further inside. That will be a into 1 upon sec of x upon a into, now derivative of sec, let us assume this as x, this whole is as x. So sec x, derivative of sec x is nothing but sec x into tan x. So sec x upon a into tan x upon a, and again derivative of this term, derivative of the third function x upon a. So first derivative of outermost function, second derivative of second function, and lastly derivative of third function. So it will be a into, this is 1 upon sec x upon a into sec x upon a into tan x upon a into, now derivative of x upon a will be 1 upon a is constant into derivative of x is 1. So here we have got the whole derivative. Now let us see what gets cancelled. This sec x upon a, sec x upon a gets cancelled. This a is in numerator, this a is in denominator, it gets cancelled. So what remains is only tan x upon a. This is the derivative, dy by dx. Now since we have not been provided with any point, so this is the value of dy by dx. Now again differentiate in order to get d2y by dx square. Again differentiate with respect to x. Again differentiating will give us d2y by dx square. Now here also we will use chain rule. This is first function, this is second function. Tan x, assume this as x, tan x derivative is sec square x, so it will be sec square x upon a into derivative of x upon a. So it will be sec square x upon a into, here as we have found here, 1 upon a is constant, derivative of x is 1, so its derivative comes out to be 1 upon a into sec square x upon a. This is the second order derivative, d2y by dx square. Now we have to find curvature, but before curvature we will have to find rho, the radius of curvature. Let us find the radius of curvature by substituting these two values. This is one value, this d2 by dx square, and this here is dy by dx. We'll use these two values to get the radius of curvature. So radius of curvature will be, let us use the formula of radius of curvature. Rho is equal to into bracket 1 plus dy by dx bracket square bracket raised to 3 by 2, and in the denominator it is d2y by dx square. So it will be 1 plus dy by dx is tan x upon a, here it is tan square will make it tan square x upon a, bracket raised to 3 by 2, and value of d2 by dx square just we have found 1 upon a into sec square x upon a. So this a will go into numerator. Here we will use one property of trigonometry, 1 plus tan square theta is sec square theta, so it will be sec square x upon a bracket raised to 3 by 2, this is square bracket, and into denominator it is sec square x upon a. Now let us multiply this 2 with 3 by 2, it will result in sec cube x upon a upon sec square x upon a. So here we get the cancellation, sec square gets cancelled with 2, 1 sec remains, so it will be a into sec x upon a. This is the value of radius of curvature, but we have been asked to find the curvature only, so here it is. Curvature is nothing but reciprocal of radius of curvature, so curvature is equal to 1 upon rho, that is 1 upon a into sec x upon a, and it is 1 upon a sec reciprocal of cos, so cos x upon a. So this is the final answer, and this is what we have been asked to prove. So it is proved. Let us see. We have been asked to prove that or show that the curvature at any point is 1 upon a into cos x upon a. So we have obtained the same expression, 1 upon a into cos x upon a, for the curvature. Okay.